Hi, this video we're going to be talking about one of the most fundamental concepts in engineering. It's dimensions and units. So let's think about examples of dimensions. For example, I could say, okay, meters, right? Foot and inches, kilogram, what else? Newton, cubic meter, liter, gallons, right? So now this list can go on and on. Or PSI, how many Pascal, all of this. So those are different type of units. And we're gonna group them together because there are several different systems. Major three ones are SI system. It's international system, and also people consider as metric system. Then there is US system. Okay. And those are the different type of system people are using. And then we're going to put them into different dimensions. For example, my meter, foot, inches, they're all in length, right? And kilogram, that's mass. So those are different dimensions. And within each dimension, there are many units. So here we're gonna look at, let's see, mass first. Then we're gonna looking at time. For example, we have second, hour, year, month. Those are the units in time. And then we also have length unit. We're going to put the base unit in that category, the base unit. For example, what's the metric? What's the SI unit for mass? That's in kilogram, right? And how about for US system? We're using pound, mass, okay? Then for time, the base unit for metric is second. Same thing for US will be second. For length, US SI is meter, and this will be in foot in US. All right. Now here I'm gonna make a note. Those are going to be our primary dimension. Because what we're about to write next is no longer primary dimension. It's derived from primary dimension. For example, area. Because area is being meter times meter, right? For example, rectangle is length times width. That's going to be meter square. I'm going to use a different color. That's going to be meter square. And for this will be foot square. And that is derived from length. It's length times length. So everything below here is going to be considered derivative dimension or secondary dimension, because they are taken out from the primary dimension. Let's continue to look. If we have area, how about we do volume? Volume is width times length times height. So it's distance times distance to the power of 3, right? It's going to be meter cube. And this will be feet cube. Let's see what other secondary dimension we can have. How about density? What's density? Density is equal to mass divided by volume. So those are mass over volume. In that situation, density is mass, kilogram, divided by volume, divided by meter cube. So that's our density, the base unit. The same thing for US system will be your mass, pound mass, divided by meter cube, feet cube. All right, let's look at other things. What other unit dimensions could we think of? You have density. How about velocity? Velocity or speed, that's what? Distance over time. So in that situation, our distance is length unit, so it's meter, taking out from meter, and divided by time, meter per second. So equivalent here will be foot per second. If you have velocity, how about we look at acceleration? Acceleration, also write as an A, that's going to be equals velocity change over, so I'm going to use V2 minus V1, final minus the initial velocity change, over time change, delta T. Delta is the change, so it's T2 minus T1, final minus the initial. So knowing that, we can using scratch paper here. So if it's a velocity change, it's going to be meter per second. That's how much difference. For example, I'm just going to write on here. For example, initial speed V1 is 1 meter per second. And then now V2 become 11 meter per second. So what's the velocity change? 11 minus 1, right? 10. And then this takes the time. The whole increase of the speed is done during the course of 2 seconds of time. So can we figure out our acceleration? That's going to be equal to V2 minus V1 divided by the time. So that's going to be 11 minus 1 divided by 2. Now let's think about the unit. 11 minus 1, that's meter per second. And this is per second. The number is 5, but the unit is meter per second square. Okay, so knowing that, our acceleration unit is going to be meter per second square. Then this will be foot per second square. Thinking about acceleration G, right? Here, make another note. G, gravitational coefficient, and we know that's equal to 9.81, and the unit for that is meter per second square. That's acceleration. All right, now let's continue. What other secondary dimension could be? How about force? Force we know is unit of Newton, but what's actually Newton? Newton is mass, kilogram, times acceleration, meter per second square. So here is another important concept I want to go over. It's called Newton's, so make a note on force. Newton's second law. Mathematically, we write force equal to mass times acceleration, right? So if it is in SI unit, in metric system, force here is going to be in Newton, and mass is in kilogram. Acceleration is meter per second square. In other words, Newton is equal to kilogram meter per second square. Now, how about for US system? Actually, here I'm going to introduce another perfect time to introduce BG system. BG is called British Gravitational System. So I'm actually going to add this rainbow color here. It's called the BG, British Gravitational System. The reason I didn't introduce earlier, because BG is very similar to US with this exception. The only exception lies on mass. In SI, we use kilogram. In US, we use pound mass. However, for BG system, we're using slug. Strange name, huh? We're going to use a slug, and everything else is the same. Time is going to be second, same. And length is going to be in foot. So they're going to be the same as US. They are very similar. Those are very similar, except just slug for the mass. Because of that, we're going to look at the difference here. So the density here will be slug. Anything involved with mass is going to be changed. Okay. So, so here for force is going to be different. It's going to be slug for the mass times foot per second square. And for that, we have a name. It's called a pound force, LBF. Okay. So that's where I am going to write it down. For BG system, the force is going to be pound force. And then the mass here is going to be slug times foot per second square. All right. Okay. And how about for US system? For US system is also using pound force. Okay. It's also using pound force. And here for US system, there's something interesting. I want to write it down. For US system is, if we're considering about the weight, okay, so it's 1 pound mass. This is a mass unit. 1 pound mass of something, of object or substance. It's going to be weighs. Now we're going to change figure out to the force now. Mass to force. Mass is different from force. That weighs 1 pound force. Have to be on our blue planet, on our Earth. Interesting. 1 pound mass of substance weighs 1 pound force on Earth. For example, if you go to grocery store and you buy 1 pound mass of apple, how much does it weigh? 1 pound force on Earth. And here I want to introduce this. We know weight is W. That's going to be our weight. Weight is equal to mass. M is our mass. Times our G, right? G is gravitational coefficient. And here I'm going to make a note. G is going to be equal to 9.81 meter per second square. And our G is also equal to 32.2, another number to remember for engineers, foot per second square, because we changed the meter to foot, right? We're going to change the numbers as well. All right, so knowing this, we said this statement, 1 pound mass is going to weigh 1 pound force on Earth, because let's see, if we're going to translate that in a mathematical equation, 1 pound force, so we're going to write down, that's our 1 pound force, right? That's our weight. How much is the mass? 1 pound of mass. That's our mass unit. And G, we're going to use our SI unit, 32.2 foot per second square. I don't want to use 9.8 because they are not in the same dimension. I want to put everything in one dimension. I made a mistake here. This is not 1 pound force. It's 1 pound mass, right? It's mass. 1 pound mass weighs 1 pound force. And when you convert mass to weight, you're going to times that G, and G is 32.2. So we learned something here. Right? We learned something because now I want you to compare this BG and US with this equation. If I write down this BG system, because we learned 1 pound force is equal to slug, the mass unit for BG, times foot per second square. Now let's compare those two equations. We notice something. They all have pound force here. They all have foot per second square. What's the difference is what's circled here. Now that derives us an important relationship. How do we relate this slug to our pound mass? 1 slug is equal to 32.2 pound mass. That's it. So far, I'm gonna just highlight what's important here because that's absolute, so we need to know. It's gonna be Newton is equal to kilogram meter per second square, and pound force is slug foot per second square. And then we know this 1 pound of mass weighs 1 pound force on Earth. We also know about slug, and one slug is 32.2 pound mass. And here, make sure this is very clear. Now let's go back now, going back to our force here. We talk about force in SI is Newton, it's kilogram meter per second square. For US is 1 pound force. And here is going to be 1 pound force, we can write it down, is basically slug times foot per second square. Now let's continue. Let's see what other secondary dimension. So we took a little detour, explain this force, explains the different units. However, this is actually one of the most important things. Now let's see, pressure. For pressure, what do we have? Pressure, we heard about Pascal, and that is the unit for SI. But what is actually Pascal? Pressure is basically force over area. Our force is Newton over meter square. So that's our Pascal, Newton over meter square. How about for SI? How about for US system? It's going to be same thing, force. What's our force unit? Pound force. And what's our area? Foot square. And there's a name for that. Pound per square foot. Pound per square foot. So it's PSF. We often use PSI, pound per square inch, right? So there's equivalent for pound per square foot, also PSF. And that is a base unit for the pressure. All right. Here I don't need to write it down for the BG because it's the same. It's all same as US, pound per square foot. All right. Now let's see what other dimensions do we have? How about energy? Energy or work, that's equal to force times distance. So it's force times distance. That's going to be our energy unit. So we learned about there's joule. That's going to be the unit for SI, joule. But what's a joule equal to? It's force, Newton, times our distance, meter. So Newton times meter is actually joule. Okay. Then how about for US system? Force is our pound force, and distance is foot. So that's going to be the unit for energy, foot pound. Pound times foot, foot pound. Okay. Now let's see what others do we have. How about power? Power, how is power related to energy? It's energy divided by time. It's time rate of the energy. So knowing that, we know power, we learned about watt, right? And what is actually watt? Watt is energy, which is joule, you get from here, divided by seconds. Okay. And how about here, for US system, it's going to be energy, it's pound, foot pound, divided by time. That's going to be our power. Okay. So that's what I have so far about those different dimensions. I'm pretty sure this list can continue. And by the way, all those are your secondary dimension. So this list can continue, but that's the major one. Let's wrap it up. There are different dimensions and different units. And there are 3 major systems, matrix system, pretty much all the countries in the world are using metric system, and US is using the US system. That's why as a US engineer, you are going to learn both. You're going to be learning US, and you also need to know how to convert back and forth between SI and US system, because it's global, right? Then we're talking about the three primary dimensions: mass, time, length, and everything else, secondary dimension, derived from this primary dimension. And realize BG, British Gravitational Unit, is similar to US, except only the mass here is used as slug. So knowing all of that, the key is to understand each secondary dimension, what they are. For example, we know power. Power is going to be equal to energy divided by time, and energy is force times the distance. Then we know how to fill up those different cells here. Now, another very important concept is F equal to ma, Newton's second law. And what's Newton? Newton is kilogram meter per second square. And what's pound force? Pound force is slug foot per second square. And also know 1 pound mass is going to be weighs 1 pound force on Earth. For example, I have a 1 pound mass of something. How much does it weigh on Earth? 1 pound force, 100 pound force. That's going to be a no-hanging fruit, right? Really easy. And knowing that, we're also going to figure out the relationship. Here, one slug, the mass is going to be equal to 32.2 pound mass. So that's all for this video. I'll see you next time. Bye.